Hello everyone. Let us attempt this problem that was asked in 2014 in set 3. The marks allotted was 2 marks. The problem statement was if G is a forest with n vertices and k connected components, how many edges does G have? So there are these 4 options given. Now we can attempt this question starting from the options. By the process of option elimination. So let us take an example and try to eliminate few of the options that we have. So we'll take a simplest forest with a single component. So as you might be knowing, a forest is a collection of trees. So a forest with a single tree would look like this. So this is a tree. A tree is a graph with no cycles, right? So this is a tree with no cycles and it is a single tree. That means in this forest we have a single tree, right? So here the value of k is 1 connected component, or in this case it is a single tree, so k is 1, and number of vertices here is 1 2 3 4 5 6, so n is 6. And here number of edges in this graph is as this is a tree, and then the number of edges would be equals to n minus 1, that is 5. We can count this 1 2 3 4 5. So number of edges is equals to 5. So now using this values of n and k and putting it in the options, if we get a 5, then it is a candidate for being a valid option, and if we are not getting 5, then it would be eliminated. So if we put n equals to 6 and k equals to 1 here, we are getting a 6, so it is not a valid option because number of edges should be 5. So this is eliminated. Similarly, this one would also get eliminated. 6 divided by 1 is 6, and ceiling of 6 is 6, so this is not 5, so this is also eliminated. 6 minus 1 is 5, so it is a candidate to be the correct answer, but we cannot say that it is correct currently, but it is not eliminated. Now this one, 6 minus 1 plus 1, that is 6, so this is also eliminated. All these 3 options are giving a value 6, so these 3 options are eliminated, only 1 is left, so this is the correct option. So with option elimination we can do it very easily by taking an example and then checking if the values of the number of edges that for this particular graph is given by which of the options, and which other options are giving incorrect values. So the options which are giving incorrect value would be eliminated, and by this, if we can eliminate 3 options, then the remaining one would be the answer. So here by grace of God we have eliminated. By taking the first example itself, we have eliminated all the 3 options, only 1 option is left, so this would be the answer, right? We could have attempted it in a forward way. So this I call it as backward way, where we start from options and then we eliminate few options, and then the remaining option is the answer. But there is a forward way, that is we can attempt to answer it in a forward way as well. So let us start with a graph. Which is a tree. So this is a tree which is having how many vertices? 1 2 3 4 5 6 7 8 vertices. So here n is 8, right? N is 8. Now it has got a single component, means single tree, right? Single component or single tree. So starting with k equals to 1, number of edges here is, so initial number of edges is n minus 1. It is a tree, of course, with n vertices, so number of edges would be n minus 1, that is 7. So we started with 7, right? Now to get two components, so this is a single component. To get two components, what we need to do here is we can eliminate an edge. So if we eliminate an edge, we get two component, right? So we started with n minus 1 edges, and then we eliminated one edge to get two component. If we eliminate another edge from this graph, we would get three components, 1, 2 and 3 connected components. Likewise, if we eliminate, so in general, if we eliminate k minus 1 edges, we would get k components. So to get k components, starting with a tree with n minus 1 edges, we'll have to eliminate k minus 1 edges from the tree. That means when we would get k components, the remaining number of edges in the forest would be equal to, so we started with n minus 1 edges, and then we eliminated k minus 1 edges from it to get k components. So when we have k components in the forest, then the number of remaining edges would be equals to n minus 1 minus k minus 1. That is equals to n minus 1. Now open this bracket, minus k plus 1. So plus 1 minus 1 gets cancelled, and we are remaining with n minus k edges. So a forest with k components would have a forest with n vertices and k components would have n minus k edges. So this is the correct answer. So I hope you have understood the logic. Thanks for watching. Bye.